Hello, Katie. This is Alina. I'm in the Congo, and I got a mysterious bite from a mosquito. Thankfully, I caught the little bloody insect, and here he is. And I was experiencing some weird symptoms, and I was wondering if you could tell me what is happening.
Hey Lena, oh my gosh, I hope you're okay. So actually the mosquito that bit you is a member of the Plasmodium, and the species is actually specifically called
Plasmodium falciparum.
Yeah, so it's actually the #1 killer of the 5 species of Plasmodium that carry malaria in mosquitoes. But don't worry, I'm sure you'll be fine. What symptoms are you experiencing, just specifically, so I can get a better idea of what's going on?
Katie, this is in reply to your last message. I'm having some symptoms. They are headache, fever, shivering, vomiting, convulsions, and retinal damage, I believe. I also get very cold and very hot. For instance, I'll have a fever and I'll be sweating bullets, and then I'll get very cold. Please tell me what's wrong.
So, Lena, unfortunately, I think that you have malaria. I'm very sorry.
Oh shit, how did this even happen to me?
I don't know how this happened. Let me refer you to my friend, Dr. David Peterson. He'll be sure to help.
Hey Lena, so Katie told me you're dealing with some health issues, and that you think you might have malaria. I just happen to be an expert in the area, so I'll just want to run you through the life cycle of the disease to just let you know more about it. So here we go. So there are 3 main parts to the Plasmodium life cycle. One part occurs in the female Anopheles mosquito, and then 2 parts occur in the human body. At this point, we're going to focus on the cycle in the human body. The 2 parts in the human body are the exoerythrocytic cycle and the erythrocytic cycle. When you are first bitten by the mosquito, infectious Plasmodium sporozoites are passed from the salivary glands of the mosquito into the bloodstream. These sporozoites then travel into the hepatocyte cells of the liver, where the exoerythrocytic cycle takes place. In an infected liver cell, the sporozoites develop into a schizone, which will undergo asexual reproduction to produce slightly altered merozoites. The liver cell will eventually rupture, releasing merozoites into the bloodstream. This is where the erythrocytic cycle takes place. Once in the bloodstream, the merozoites infect the red blood cells. Here they develop into trophozoites and absorb nutrients from their hosts. This trophozoite then develops into another schizone, which will produce more merozoites similar to in the liver cells. The red blood cell then ruptures and releases these new merozoites into the bloodstream, where they will infect new red blood cells. Since Plasmodia are apicomplexans, they infect cells by using an apical complex. This cycle of infections in the bloodstream is responsible for the reoccurring fever that is symptomatic of malaria. Also, not all infected red blood cells develop into trophozoites and schizones. Some will develop into gametocytes that, when taken into another mosquito during its blood meal, will combine sexually to restart the cycle. So I know that might have been a lot to comprehend and slightly overwhelming. So here's a video to try and help make things a little bit more clear for you.
The malaria life cycle follows a devious path, swapping back and forth between mosquitoes and humans. This mosquito is infected with the malaria parasite. Because she is pregnant, she has become hungry for human blood. During the bite, she injects saliva to stop the blood from Her infected saliva also carries the malaria parasite. The parasite rides the bloodstream like a network of roads, seeking its first target, the core of your body's blood system, the liver. Sensing its arrival at the liver, the parasite searches for an exit. A sentinel Kupfer cell is the entry point to liver tissue. Leaving the blood, the parasite infects a liver cell, killing one or more other cells on its way. Over the next few days, the parasite undergoes hundreds of nuclear divisions, copying its DNA over and over again. A single infected liver cell can create thousands of new parasites. The next generation of parasites are modified to infect a new target: red blood cells. Inside a red blood cell, the parasite can hide from the body's immune system. The parasite slowly devours the contents of the infected cell and creates more parasites. The infected cell is sticky and jumps onto blood vessel walls. Once mature, the infected cell bursts, spreading more parasites through the bloodstream. Malaria victims suffer fever, loss of blood, convulsions, brain dam, and coma.
So just keep us posted on how you're feeling tomorrow and over the next couple of days, and see if you can get some blood samples to Katie for some testing, and then we'll go from there.
Hello, David. This is Alina. It's the next day and I'm not feeling any better, so I was looking up some cures for malaria. There are 3 ways that you could treat malaria: by medication, mosquito elimination, and prevention of bites. Now, mosquito elimination you can do with pesticides, but sometimes the mosquitoes can become resistant to the pesticides, and then that doesn't work. You can prevent the bites by sleeping in a fishing net, but I'm not a fish. I don't sleep in fishing nets. Another way to prevent the mosquito bites is by sleeping in a mosquito net. However, I already have malaria, so that won't work. The third way is to treat malaria with drugs or medications. Usually, these drugs or medications are combined with one another in combination therapy. There are 2 types of combinations that are used to treat malaria. One is non-artemisinin-based combinations, and the other is artemisinin-based combinations. You can only combine certain drugs with artemisinin, a drug used to treat malaria, because if you combine a certain type of drug that is non-artemisinin based with artemisinin, it will cause resistance to the artemisinin drug, and hence nothing will happen. All drugs that are used to treat malaria are suppressive prophylaxis, and that means that they are effective at killing the malaria once the parasite enters the blood stage, which was explained by David. Artemisinin is a drug that is often used to treat malaria. It is from a Chinese herb that has been used for thousands of years. What happens with artemisinin is that when the parasite enters the red blood cell, artemisinin can change the redox homeostasis of the parasite, causing its death. Two drugs that are often used in combination therapy that are non-artemisinin based are doxycycline and quinine. Doxycycline was founded in the 1960s in America. It is used often today to treat malaria because it is an over-the-counter drug and it is fairly cheap. It is also used to treat acne and Lyme disease. The drug doxycycline impairs the progeny of the apicomplex genes, resulting in their abnormal cell division. Now, as you know from David's video, the parasite that causes malaria is an apicomplexan. Doxycycline cannot be used as the initial treatment for malaria. It must be combined with another drug due to its anti-malarial effect being delayed. Therefore, you need a precursor drug before you can use doxycycline. A drug often used in combination therapy with doxycycline is quinine, a crystalline alkaloid found in Peru in the 17th century. It comes from a chinoa tree. This was the first treatment used for malaria, and it has the most amount of side effects, which is why it has been replaced with artemisinin-based drugs in the future. The drug quinine produces a cytotoxic heme or protein that causes the parasite that causes malaria's death. This drug, along with doxycycline and artemisinin, are among a number of drugs that will treat malaria. But what I want to know is why malaria will kill me in the Congo. Please get back to me, David or Katie.
Well, Elena, I mean, if you were in the United States or, say, Europe or some other developed country, you would have access to all those awesome drugs that you just listed. But you're in the middle of the Congo. So unless you can find a way to get out and get access to those drugs, we're going to have to, airlift you a bunch of drugs or something and just drop it from a helicopter. But can you actually send me a blood sample if possible? Because I'd like to do some further tests and just officially diagnose you. So right now we're kind of just going off the fact that you have all these symptoms and that you were bit by a mosquito. So if you can get back to me as soon as possible, that would be great.
So, Katie, I'm sending you a blood sample right now so you can diagnose me with malaria, and that way you can send me these drugs if I need to be cured. Get back to me as soon as possible.
Hey Elena, hey David. So Elena, I got your blood work yet, and I don't think you knew this, but you're a carrier of the sickle cell trait, and this is pretty important for my diagnosis of you. Because people who carry that trait are immune to malaria, you silly goose. So, see, it's a recessive gene. So, in a person with 2 copies of the recessive sickle cell gene, the hemoglobin molecules in the blood distort, or sickle, where you get the name, so that the molecule is not effective in releasing or taking in oxygen. Here is an example of a sickled red blood cell, labeled on the left. However, if you're heterozygous for this trait like you are, your red blood cells don't sickle to any significant degree unless they're experiencing very low oxygen tension. So don't go hike a mountain anytime soon. But it prevents malaria, going back to that low oxygen tension, because the presence of the falciparum parasites reduce the oxygen tension of the red blood cells. So this basically causes them to sickle and distort, and the falciparum have nowhere to complete their life cycle in the cell, and they die. So basically, I don't even think you have this disease because you are a carrier of the sickle cell trait, and some of your red blood cells in your blood sample were all sickled and distorted. So the falciparum haven't been completing their life cycle in your red blood cells. So basically, I don't think you have this disease. I think you might just have the flu. Thankfully, Elena's okay. However, malaria is not a disease to be messed with. In 2010 alone, the WHO recorded 216 million cases, resulting in 655,000 deaths. That's about 2,000 a day, and these are only the deaths that were documented. The estimated total of undocumented and documented cases of deaths is 1.24 million. Malaria is most common around the equator, specifically in the regions indicated in red. The dark red indicates the regions where it is most popular. The sub-Saharan area of Africa is where 80 to 90% of the deaths were documented. So we're just seeing if the sound's working.
Yay.
Hey.
Wait, see how it's slow?
Is it slow?
Do you see that? It like...
Hey Lana, so the mosquito that bit you is actually a carrier of this nasty protist. I don't know what to do.
Yeah, go now.
Hey Lena! Oh my gosh, I hate you! I think you have malaria.
Katie, this is in your...
And what I deduced from the mosquito carrying the Plasmodium species. I can't do this!
You look so bored, you're like... How did this even happen to me? Oh,